Hello, everyone. Back to another thrilling math lesson. These are the notes from the other day. The lesson 3, washer and disk. We did everything disk so far. The homework problems that I had you skip were 33, 39, and 40. So I'm going to ask you guys to go through those. I'm going to go over and finish up the notes. I already have the pre-drawing here, but just so you understand what I'm talking about, these notes right here. The blank copy was already posted on Classroom, as was the filled in copy. So all of this work is already here, but if you want to see a video and get a little bit of my explanation, here we go. So that's the picture. We've got the blue graph representing radical x. We've got the red graph representing y equals x squared. We don't know the bounds. Actually, yes, we do. We're going from y equals 1 and x equals 1. So we just got to figure out how we're going to do this using a slice. And if we scroll back up in the notes, I'm hoping that you guys didn't ignore A, this problem right here, which is pretty good, and B, the summary that goes with washer and disk, which for some reason is not here. I'll have to pull that up. All right, that'll be later on. So we're going to look at this, and I'm going to take this little like feather-like region, and we're going to rotate it around the x-axis. So we'll almost get like an ornate vase. All right, there we go. Why is that there? Boom. Okay, so first thing I'm going to do is draw a slice, and we're going to try to rotate this slice right here around the x-axis. And you'll see that if we do this, we have this guy coming out and around, and we're going to have a space that we don't want to be included. All right, so this is the slice that we want. However, this is not going to be the best way to think about it for our first go. All right, Khan Academy assignments were also scheduled today. So let's talk about this. If I want to rotate around the x-axis, I'm going to use the disk method. I'm just going to do it twice. So if I want to rotate just the region of the blue graph around, it would be a cylinder. And I'm just going to label this V out for V outer, the volume of the outer piece. And I obviously, if I'm using the word outer, you can probably think there's going to be an inner. And then our answer is going to be some version of an operation having to do with those. So let's think. My radius is going from here to the top, or well, not the top, but from here to a value on radical x. So my radius is going to be this height right here, this y value, which is better known as f of x. So the outer is still a cylinder. The volume formula for a cylinder hasn't changed, pi r squared h. And right now we're kind of hanging out right here. Okay, now if I rotate this thing, again, I'm going to try to draw my best three-dimensional cylinder. And we're living right there. I'm going to turn that bad boy on its side. And we're living right here. And therefore, this piece is my delta x. It becomes the height of the cylinder. So this is where I live, right there. V out. V in is going to be the exact same thing. I don't know if these colors are really showing up. I hope they are, but that's purple. Maybe on your screen it will. I don't know. So the inner piece is now going to be, we're thinking just the inner part. We're going to have to change out that. I'm going to write over this one. So my inner volume is still another cylinder, but this is going to be kind of a different way of thinking about it. I'm going to find all the cylinders that are not in the region that I want. So basically all the stuff that's not in the region in this big gap space from here to 1. Okay, that's 1. This is also 1 up here. So the idea is if I have everything underneath the blue curve, that'll include all the stuff underneath the purple curve. And then if I subtract out the stuff underneath the purple curve, I'll get exactly what I want, which I'll draw in a sec. So still a cylinder, still pi r squared h. We have a pi, but now the height, my radius is measured from the axis of rotation to the edge of the region. The edge of the region is the boundary of the purple graph, which is g of x. And now if I want my actual volume, this is pretty cool. I'll show you this. So here we go. If I do blue, I was talking about everything. If I do purple, I was just talking about this guy right here. And if I subtract the volume of the outer and the inner, I'm going to get the region that I want rotated around. So my total volume is going to be V out minus V in, which is cool. And I think we got this down. I'm going with respect to X, and the X's live between 0 and 1. So those are the limits of my integration of pi. All right, so if I'm subtracting these, I can factor out the pi. And then I can also factor out the delta X. And what's going to be left over is going to be f of x squared minus g of x squared. So it's going to look like this. What was f of x? It was radical x squared. G of x was x squared squared. So here's our pi. R squared minus big R squared minus little r squared. So the general formula for the washer method. And why is it called a washer? Well, a washer, like what you put with nuts and bolts, looks like this. So it has a hole in the middle. So it's basically this method where we take the volume of the entire region and subtract out the stuff that we don't want included, hence the hole. So the idea there, the general formula is V equals the integral from a to b of pi cap r squared minus little r squared. And then I'll put dr because we have to figure out if r is in terms of x's or y's, then that'll change this to x's or y's. All right, so we live right here, and then this is a pretty easy integral. So this was in general. Bounce that up a little bit. Let's just clean. I'm going to have pi 0 to 1. Dirty math. Clean it up. Here we go. And then let's see. I'm going to get pi, and then my integral is going to be a half x squared minus 1/5 x to the 5th from 0 to 1. So it's going to be pi. And then I'm going to have a half minus a 5th. And then everything else zeroes out. So I'll put the minus 0 for those of you that fell asleep during my soothing voice. And if I want to do this, a half is 5/10, and a 5th is 2/10. So 5 minus 2 is 3, so it's 3/10 units cubed. Cool. Ooh, there we are. All right, I'm signing off for now. I'll post this. Peace out.